Hey guys, it's Mrs. Winger. Welcome back. Today we're going to review section 6.5 and 6.6. In these sections, we learned a lot about expanding and condensing logs. So let me just remind you a few properties of logs. These are three of the main ones. So the first one is when you have the log and you have two things multiplied together like this, you can expand it. Notice they both have log base b, so it has the same base as the original. And you can expand it by adding them together. And this just comes from, remember logs are really just exponents. So this comes from exponent rules when you have something like this up here, and we know that because you have the same base and these are being multiplied that you add the exponents together. So this answer would be x to the fifth. So it kind of helps explain a little bit why down here we would end up adding the logs together. It's the same reason that we would add these exponents together. Okay, so similarly, if we had two things with the same bases and they have an exponent and they're being divided, like this one down here, we know that we would subtract these exponents, which explains why in the second rule, where you are dividing two things, you would subtract the logs. Okay, and then the last one is when you have something like this down here, I can expand this by rolling this exponent out to the front. Alright, so let's practice that a little bit with a few examples. So if I was asked to expand ln of 5x to the 7th over y, so first of all, is this a log? Yes, ln is a log. It's just the natural log. So the first thing I would do is notice that we have a division sign. So I would separate this out by subtracting the two things, like this. And then the second thing I would notice is that in the first term, we have two numbers being multiplied, 5 and x to the 7th power. And what do we do with two things being multiplied? We can add them together with the same base. So I can write it out like this. So everything in the blue box became this blue box down here where they separated out with the addition sign. And then lastly is this term right here still has an exponent on it. I know that I can roll that out to the front. So let me write that in the third line. This will stay the same, this 7 will come out in front, and this last term will stay the same. And this is my final answer. I don't have any more exponents on things. It's fully expanded as much as possible. So that would be my final answer. Okay, so let's do the opposite. Let's now take something that's already fully expanded and condense it back together. First thing I notice is that I have this coefficient of 3 in front. That means that it would have been the exponent on the 2. So let me just write that middle term with 3 as the exponent. Okay, so that's all I've done is done the middle term. And so now let's start looking over here. I see that I have a plus sign in between, which means these two things would have been multiplied together with the same log. So it would look like this. By the way, we are working with log base 10 here. Although there's no number written right here, we know that it's base 10 just because there's no number, and that's the standard form for it. The second thing is we have this subtraction sign, which means this term right here, it would have all been divided by that. So I'm going to add a divided by 3. And I can just simplify this together like this. And when I calculate this out, 9 times 2 to the 3rd power divided by 3 gave me 24. Okay, so now I'm going to have you try 4 of these on your own. 2 of them where I want you to expand and 2 of them where I want you to condense. Let me get you started with a couple hints on the first 2. So in the first one, I have 2 terms. I have 3 and I have x to the 4th. Since they're being multiplied, you know you're going to expand it out by adding them together using the same log of base 6. Keep in mind there's an exponent right here, so eventually that will need to get rolled out to the front. In the second one, you have a division sign, which means you need to subtract them. So you need to be doing ln 5 minus ln 12x, and I'll let you take it away from there. So I'm just going to erase my screen, give you a second to pause it, and work on these 4. Alright, so I've boxed in my answers. I'm going to talk you through the second problem because I'm guessing some of us probably messed up this sign right here, maybe wrote it as a plus sign. I will talk you through that, but I want you to just take a second before I make this screen super cluttery, pause it, check your answers, and then I'll walk you through number 6. Okay, so in number 6, the reason why that second sign is a subtraction sign is because you're doing ln of 5 minus ln of this whole thing. So that's why I put this in parentheses. Everything in parentheses right here represents what I just circled in green over here. And so since you're subtracting that entire thing, that subtraction sign needs to get distributed to both terms, which is why in the end, this one became a negative. So just watch out there and be careful. Number 8, some of you might have left it in this form. I would go ahead and multiply and calculate what those numbers are, since they're pretty easy numbers to calculate, and they end up giving us an integer answer anyways. So write your final answer as this one. Okay, so let's move on to change of base theorem. So if I'm asking you to evaluate something like this on your calculators, using a common log or a natural log, there's a really simple change of base formula that we can use for this. And that formula is that you're going to do log of the second number, so log of 8, divided by log of 3. Now, since I'm not writing a base here, I know that I'm talking about log base 10, but I don't need to write that in. Remember, log base 10 is what is called the common log. So when it says use common logs, I know that I'm using log base 10. So I can type that in really quickly on my calculator. Log 8 divided by log 3, that's going to give me about 1.893. And this gets really helpful later when we start to solve equations, where in the middle of it we have something that's not a common log or not a natural log, to be able to do a quick conversion. Okay, so let's do the exact same thing using natural logs. The formula is the same. The formula is the same for any log that we want to change it into. You're going to do the second number, so 24, divided by the first number, which was 6. So it works with log base 10. It works with ln, the natural log. It'll work with any log you want, any base that you want. Typically, the ones that we always ask you to do for your change of base formula is the natural and the common log, which is base 10. So when we type this on our calculator, we get about 1.774. So these are really quick, easy problems when this is all that's involved. And again, why this is helpful is because you'll be doing this in the middle of solving an equation here very soon. Okay, so let's work on solving some equations. How do I solve for x when x is stuck in an exponential like all of these are? So when it's stuck in an exponential, you are going to logify both sides to get it to get the exponent out. So let me just remind you, log base b of x and b to the x power are inverses of each other. This is from the last lesson. And so we can use that fact to help us solve equations. So if I want to get x out of this exponent, I will just logify both sides using a base of 2, since that was my base over here. So writing that out would look like this. I have log base 2 both sides. Notice what's in this green box and what's in this green box is just the original problem. So if 2 to the x is equal to 5, then it's true that if you take both of those things and put it inside of the same log, it will still be equal to each other. And now the nice part about that is log base 2 and 2 will cancel because they're inverses of each other. And so what I'm left with is x equals log base 2 of 5. Now I can calculate that really quickly using the change of base formula that we had just did. So on my calculator, this is what I'm going to type in using my change of base formula and see what I get. When I type that in on my calculator, I'm getting about 2.807. And so I've just solved for x. Take a second now and pause the video. If you need to look at my work thoroughly, I'm going to clean the board before I go on to question 2. So in question 2, my variable x is stuck inside of an exponential and the base is 7. So I'm going to logify both sides with a log base 7 to get rid of it. And writing that out would look like this. And the awesome part is that this 7 and log base 7 will cancel, so I'm just left with 9x equals log base 7 of 15. This part right here I can calculate using my change of base formula. So writing it out would look like this. When I type this part into my calculator, I'm getting about 1.392. I'm going to take my work and bring all of this up here. So what I have is 9x equals 1.392. I'm going to write dot, dot, dot because I'm going to keep that exact number in my calculator so I don't have any rounding issues. And the last thing I need to do is just divide both sides by 9 to get x by itself. So in my calculator, I'm going to already have left that one in for my previous answer. So you're going to do answer divided by 9, and you should get about 0.155. And that's my final answer. If you need to pause the video and look over this work, go ahead and do that now before we start number 3. So number 3 might look overwhelming, but it's really not. They've just added a couple things that we need to do first. Just some basic things like from Algebra 1. Let's start to get the variable by itself. There's some other things in the way that we can move, like that -7. We can really easily move that to the other side to make this look more simple. The other thing I can do is divide by 4 to make this look more simple. So writing all of that out gives me a much simpler equation that looks like this. And now I can start doing Algebra 2 work on it, which is to somehow get the x out of the exponent. And how I'm going to do that, I'm going to logify both sides, this time using a base of ln since my base was e. And again, the nice part is that ln and e will cancel, so what I'm left with, let me bring it up over here, is negative 0.3x equals ln 5. And to get x by itself now, all I have to do is divide both sides by negative 0.3, and that's just a simple thing that I can type on my calculator. And you should be getting around negative 5.365. Alright, so let's do the next type, where x is not stuck in an exponent anymore. Notice in both examples, x is stuck inside of some sort of a log. So to get it out of a log, I'm going to exponentiate. So think about the last slide. When it was in an exponent, I logified both sides, and when it's in a log, I'm going to exponentiate both sides. I'm going to choose to do a base of 2 on this example since the log was a base 2. So let me write that out. Okay, so just taking this and this, which were the two sides of the equation, and I put them up inside as exponents with a base of 2. That's what I'm calling exponentiate both sides. And when I do that, this log base 2 and the base of 2 will cancel each other out, which will leave me with a really simple equation like this. 5x minus 17 equals 8. I wrote 8 because I just evaluated 2 to the 3rd power. And now this is just a simple thing from Algebra 1 where I'm going to solve x in the regular way. And that will leave us with an answer of x equals 5. Okay, pause your screen if you need to look over this work before I clear it off and do part B. In part B, this looks a little bit harder because we actually have 2 logs instead of 1. The good thing is they both have the same base. Notice both of these are the common log with a base of 10. So I can use my rules of condensing to put both of these together into one log. And what rule am I going to do? Since there's a plus sign here, I can take both of these terms and multiply them together and put them inside of one log. So it would look like this, 2x times the whole thing of x minus 5. And before I move on any further, I still need to write this part on the other side equals 2. But before I go any further, why don't I just distribute that to both terms so I don't have to keep it looking weird like this. Alright, so I distributed out the 2x. I also put in my equals 2 on the other side that we were missing just because we didn't quite have room on that top line. And now let's keep going with solving this equation. I still have my variable x stuck inside of this log function right here, and that is the common log base 10. So what I'm going to do, just like in example A, is exponentiate both sides with a base of 10. So I'm going to take this whole side of the equation and this whole side of the equation and put it up in an exponent, and that will look like this. So I still have the equation, it's just that it's in as an exponent with a base of 10. Okay, and the nice part here is that log base 10 and 10 will cancel. So I'm just left with a really easy quadratic now of 2x squared minus 10x equals 100. I got 100 by just simplifying 10 squared. So now this is just a simple quadratic that we've solved a lot of times now, by now. And it's always easier when this over here is 0, and so I'm going to subtract by 100 to get the other side to be 0. And I can either solve this by factoring, or worst case scenario by doing the quadratic formula. When I write this out, it's becoming really clear to me, though, that everything in this equation can be divided by 2, so I'm going to do that to make life a lot more simple for me. And here's what I got when I do that. And now I just want to think through quickly if this can be factored, because that's going to be a lot faster than the quadratic formula. Can I think of any factors of 50 that will add to get me negative 5? And ones that come to my mind right now is negative 10 and 5. When I multiply those together, I get negative 50, and when I add them together, I get negative 5. So let's factor this equation right here using those terms. And over here, I wrote what that looks like factored, which now we know will give us a nice easy answer of x equals 10 or x equals negative 5. Now remember that we cannot take the log of a negative number, so I do want to go back and plug these in and double check that we don't have extraneous solutions. If I plug in negative 5 for x right here, that log will be log of negative 10, which we cannot do. And so I know that this would be my extraneous solution, so I'm going to cross that off. Before I circle that x equals 10 is my answer, I want to double check that if I plug in 10, that I won't get any extraneous solution. So if I plug it into the first log, that'd give me log of 20. There's no issue with that. If I plug it into the second log, that would give me log of 5, and there's no issue with that. So I know that x equals 10 is my final answer, and that is my only answer. All right, and that's it for today, you guys. If you want to pause the screen right here to just look at all my steps and write it down a bit more slower, you're welcome to do that. I'm going to erase the board in a second. Step into office hours if you guys need some extra help, and have a great week.